Hello everyone, welcome back to our channel, Anik Study Hub. I am delighted to see you all once again. Thank you for liking my video, thank you for subscribing, and thank you for all your comments and all your shares. I really appreciate. Thank you. So we're kicking off today with our first topic, and guess what? I decided to choose indices. Why? Because I found out that a lot of students find solving indical equations difficult. This could be due to the fact that they can't remember or they don't know the rules guiding indices, or they can't solve other equations relating to indices. So due to that, I have decided to choose indices as our first topic. So sit back, get your notes, and follow up. If you have any questions, put it down in the comment section and I will always be here to respond to you. Let's get on with it. So before I start, or before I define, or before I explain, I want to illustrate how we can easily understand the concept of indices. Let's look at this. You know that 2 times 2 times 2 is the same as 2 raised to the power of 3. Now, here, the 2 is known as the base, while 3 is known as the power, index, or exponent. What this simply means is that instead of us writing 2 in multiple ways, we can just pick one and write the number of the 2's that are here as the power, or the index, or the exponent. So here, this 2 that is here is known as the base, while this 3 that is here is known as the power, the index, or exponent. And please take note that this word index is the singular form of indices. So you can call this 3 here, this particular 3, you can call it the index, you can call it the power, or you can call it the exponent. Therefore, indices refers to the power or exponents in a number expression. Let me recap. I said something that this 2 here is the base, this 3 can be referred to as the index, the power, or the exponent. And with that being said, indices simply refers to the power or exponent in a number expression. Now, forging ahead, we have rules guiding indices. You cannot just come and see examples or simplifications in indices and assume that it can be solved just like that. There are rules guiding the principles of indices, which makes it easier to solve when you know the rules. So let's get on with it. Rules of indices. Firstly, we have the product rule. Secondly, we have the quotients rule. And thirdly, we have the power rule. We have the negative index. Number 5, we have the zero law or rule. Number 6, we have the power of the products. And lastly, we have the power of quotients. Also, number 8, the root law or the root rule. So firstly, we are going to look at number 1, the product rule. Here, when the bases are the same, to be multiplied the powers will be added. Here, when the bases are the same to be multiplied, the powers will be added. For example, if we have 2 raised to power 3 times 2 raised to power 1, how can we solve this? So far, these bases are the same. 2 here and 2 here are the bases, and we are multiplying these two numbers. Look at the powers and add them. So our solution is going to be 2 raised to power 3 times 2 raised to power 1 is equal to 2 raised to power 3 plus 1. And our final answer is going to be 2 raised to power 4. That is our answer. So if we have another example, let's make this example 1 or I, and here I. If we have, let's assume 3 raised to power 6 times 3 raised to power 5. So far, these bases are still the same. You end up adding their powers. So this gives us 3 raised to power 6 plus 5 and is equal to 3 raised to power 11. Final answer. So we go over to the second one. We have the quotient rule. Here, when the bases to be divided are the same, the powers will be subtracted. For example, let's assume we have, example I, let's assume we have 6 raised to power 4 divided by 6 raised to the power of 1. So from the notes here, we said when the bases to be divided are the same, the powers will be subtracted. While in product, when the bases to be multiplied are the same, you add. So since the bases are the same here and we are to divide here, we pick one of the bases, which is 6, and subtract their powers. 4 minus 1. This will give us 6 raised to the power of 3. Let's assume we have example II, and we have 5 raised to the power of let's say 2 divided by 5. How can we do this? This is very simple. For every number that stands on its own, automatically it has or it is raised to the power of 1. So therefore this becomes 5 raised to power 2. 5 raised to the power of 2 divided by 5 raised to the power of 1. So we'll pick one of the 5's and subtract their powers. So our answer can be 5 raised to the power of 1 or just 5. But since we are dealing with indices, it is advisable to leave your answer in index form, where 1 is the index, the power or the exponent. And moving on to the third one, we have the power rule. Number 3, the power rule. This is simple. So here, when a base has a power that is raised to another power, now what do? You simply multiply the exponents and keep the same base. Yes, this is quite simple. In indices, in power rule, when a base has a power that is raised to another power, what do? You pick the same base and multiply their exponents or power. So for example, we have 3 raised to power 3 that is raised to the power of 2. So what do? We say 3 raised to the power of 3 times 2. That will give us 3 raised to the power of 6. More so, we can have 2. This is I. Okay, let's not use 2. Let's use 5. Let's use 5. If, for example, we have 5 raised to the power of 4, which is also raised to the power of 2. What do? The same process, you pick the same base and multiply their powers. So this gives us 5 raised to the power of 8. The fourth one, negative index. Here, a number raised to a negative power is equal to its reciprocal of the corresponding positive power. This rule is simply to eliminate or to remove the negative sign. So here a number or base raised to a negative power is equal to its reciprocal of the corresponding positive power.